Well, hello there. This is Dr. Dell, and this is the video where I promised to show you the solutions to the three problems that I posed at the very end of the first video you watched. Now, the other things I promised you on that video are available in the PDFs that you can now download that are available to you. So this is the video where I talk about these three problems. The idea of them is to show you how geometry and algebra and trigonometry are really integrated together. So let's take a look at this first problem. And I'm going to do it the way we would learn to do it in the foundations course. So it's a practical math course. And here it is. You've got a circle and you have an inscribed triangle where this is given to be the diameter. And the first thing that you learned in geometry, one of the things you learned is that when this is inscribed in a semicircle, this angle, it's a right angle. So you have a right triangle. Now, you've learned from geometry, one of the basic things you learn is how to find a third side when you know two sides of a right triangle using the Pythagorean theorem. And we'll do that very quickly here. Let me see if I can get this so you can see it all. We take 5.7 and we square it, and we add that to 8.4 squared, and we see what that sum is, and we take the square root, and that is 10.15, or I will fix this to one decimal place, 10.2 is the diameter, and I wanted the circumference. Well, we know that the circumference is pi times the diameter, so we'll take this diameter times pi and add equals, and the answer is 31.9, and that's just that easy to do. But we combined, that's if you know what to do. We combine a fact from geometry, we use the Pythagorean theorem, we use some algebra, and some other facts about geometry, which is circumference of a circle. Now the solution is at the bottom of this, just what I did here. So you'll be able to, when you get the PDF of this, download it, you'll be able to follow that if you didn't follow it in the video. Although I would encourage you to try to follow it in the video and try to do it yourself. I hope you've already tried these. Now here is another problem. It's looks a little bit familiar. You have got a triangle here. This is given to be a tangent line, and this is a diameter, and this is 57 degrees, and you know the length here of 13 inches. And I've asked you to find what I want to know, the area of the circle. Well, to know the area, you need to know the radius, pi r squared, but first, what's the radius? Well, now this is a right angle because this is a tangent line, and you might be tempted to say, well, maybe I can use a Pythagorean theorem, but you only know one side. However, what you do know is an angle. So now you can use basic trigonometry. You learned in trigonometry that if you take 13 and divide it by the length of this other side, this is called the adjacent side to 57. And by the way, I'm assuming now you know trig. 13 over d is the tangent of 57. Now you apply a little algebra. You flip and do what we teach you to do in algebra, and you take 13 and you divide by, we put in 57 degrees, we take the tangent, we hit equal, and we get 8.4, and that will be this diameter. I want to know the area, so I'm going to divide that by 2. That gives me the radius. I'm going to square the radius. I'm going to multiply that by pi, and I'm going to get 56 is the answer. And so there you have it, 56 square inches. Now I've done some rounding off, and if you do it a little more accurately, you might find it's a little bit different from that, but that's approximately the answer. And I put the answer down at the bottom. In fact, at the bottom, I give it 55.4. And that was a little difference there because of round off error, which I talk all about, of course, in the foundations course. And now the last problem was actually one that is actually surprisingly difficult, probably the most difficult of the three. I gave you a triangle, and I told you the lengths of three of its sides. It's three sides, 8.5 feet, 9.4, 15.7, all in feet. And of course, as you know, you should know, these all have to be in the same units, which they are. And I want to know the area. Now, the formula that you usually learn in high school is 1/2 base times height. And that's fine if you know the height, but you don't know the height in any one of these directions. So now you can't use that. So this is a case where you really actually have to, well, there are ways to do it without trigonometry, but the easy way is to use trigonometry. At least that's what I consider the most easy way. And basically I use what is called the generalized Pythagorean theorem, which we teach, of course, in the trigonometry and the foundations. It's also called the law of cosines. And now, if you practice this a few times, do a few problems, you get to where you can do this very rapidly and very easily. I'm going to, as a matter of fact, I'm going to take these two sides and I'm going to apply the generalized Pythagorean theorem. And I'm going to assume you know what it is. Now, if you don't know, you'll barely follow this, and you'll obviously need to go and learn about the law of cosine somewhere, maybe Khan Academy or wherever you want to go, Wikipedia, anywhere else. We're going to take 8.5 squared, and we're going to add 9.4 squared. We're going to subtract 15.7 squared, and we're going to get equal. And then we know that we have to divide, according to law of cosine, by 2, equals, we have to divide by 8.5, equals, we have to divide by 9.4, equals, and that is going to give us then the cosine of this angle, and I'm going to take inverse cosine, and that gives me that angle. Now, once I know that angle, we learn in basic geometry a formula for the area. If you know two sides and included angle, take the sine of that angle, you multiply that times 0.5, you multiply that times 8.5, you multiply that times 9.4, and you hit equal, and you get 33.7 square feet. And that indeed is the answer then. And you could have used this angle up here and done a similar thing, and you would have gotten the same answer using the generalized Pythagorean theorem. Now, if you don't know trigonometry, if you don't know the things we're talking about, this probably all seemed like nonsense to you because I went pretty fast. I'm doing it the way you would learn to do it. This is something that we teach in the foundation course in the trigonometry section because it shows it's a good example of how you do problems in the real world. This is not something you might find in a lot of math textbooks because it's too hard to use the formulas they tend to give you sometimes. So anyway, this is problem number 3. Now, this was the video I promised you. You have some PDFs to download, and the information I promised in the first video you watched will be given to you in those PDFs. I'm also going to be sending you a series of emails where I will tell you more stuff, and I will have some more videos for you to watch on different topics, and we're going to basically hopefully start a dialogue. We also are going to send you to our website where we have a sort of a forum that you can participate in. You can ask questions and that sort of thing too, if you care to. And that's our way of getting a relationship started. If at any time you get bored with the emails or you don't want any more of them, just unsubscribe, and that'll be the end of it. We'll remove you from the list and you won't get any more emails from us. Our goal is to have you learn mathematics, or if you're helping someone else learn it, have them learn mathematics as efficiently and painlessly and with as much fun as possible. And we believe that is possible to do with a lot of fun. So this is Dr. Dell signing off. Thanks for watching this video, and I will be communicating with you through some emails and some additional videos. And so hopefully you are well on your way now to learning mathematics or helping someone else learn it. Bye-bye.